Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will understand the concept behind Hough transform. So first of all, what is Hough transform? So Hough transform is a popular technique to detect any shape if you can represent that shape in a mathematical form. Hough transform can detect the shape even if it is broken or distorted a little bit. Now this explanation might seem a little bit confusing, so let me explain it by an example. So let's say you have an image of this road and you want to detect these lane lines in this road image. So the first step in order to detect these lane lines in this road is to find the edge pixels using Kenny edge detection or any other edge detection method. Now after you found out the edges using any edge detection method, you want a geometrical representation of that edge. And in order to find out the geometrical representation, for example, you want to find out the slope of this edge or its intercept, you can use Hough transform to represent these pixels or edges in the mathematical or geometrical form. So after you find out the edges using any edge detector, you just have the sequence of pixels, so you can loop through all the pixels and somehow figure out the slope and intercepts, but it's a very difficult task. So we want some mechanism that gives more weightage to pixels that are already in line, and this is what we can achieve using Hough transform. So let's begin and let's start with the lines. So a line in the image can be represented by two coordinate systems. First is using the Cartesian coordinate system, and using this equation you can represent a line which is y is equal to mx plus c, and you can also represent this line using polar coordinate system using this equation, which is x cos theta plus y sin theta is equal to r or rho sometimes. So let's start with this equation first, which is a Cartesian coordinate system equation, which is y is equal to mx plus c. So when you represent a line in x and y coordinates, which is also called the xy space, this equation looks like this. So y is equal to mx plus c, where m is the slope of the line and c is the intercept of this line. So if you know the values of m and c, you can represent this line in the x and y coordinates. Now in Hough transform, you can represent this line in other form also, and this is called the MC space or the Hough space. So using this equation, when you take m on this axis and c on this vertical axis, then this is called the MC space. So earlier we have represented this line in the xy space, and now we are saying that we want to represent this using the MC coordinate, where m is on the horizontal line and c is on the vertical line. So when you represent this simple line in the MC space or the Hough space, it can be represented as a point. So this line can be represented as a point. So we all know that a line is a collection of points, and managing the collection of points is tougher than managing a single point. So if you want to manage a collection of points, and if you were to manage a single point, which will you prefer? And an obvious answer will be to manage the single point. And this is what this MC space is doing. It's representing a line in the form of a point in MC space or the Hough space. And the opposite of this concept is also possible. So if you can represent a point using these coordinates in the xy space, then it can be represented as a line in the MC space. okay, and the formula now will turn into this equation, which is c is equal to minus xam plus ya, right? So you can represent a point, and if you have the x and y coordinate in the MC space, you can represent this as a line, and this will be the equation where x will be the slope now and y will be the intercept. Earlier m was the slope and c was the intercept, but when you just transform or just represent this point into MC space, then your x becomes, or minus x becomes the slope and y becomes the intercept. So how does these concepts are going to help us? So the Hough transform is all about doing what we have learned, converting points in the xy space to the lines in the MC space or the Hough space. So for example, you can see 4 points, 1, 2, 3, 4, which are joined by a line, right? So you can represent these 4 points and you can join all these 4 points, and it's a representation of a line, and here slope is equal to m and intercept is equal to c in the xy space. The same line you can represent in the MC space using these 4 lines. Okay, so every point is a line in the MC space, and you see the intersection point here, which is on the MC coordinate. So you have taken an edge detected image, and for every point that is a non-black point, you draw lines in the MC space. And obviously when you draw these lines will intersect with each other, and these intersections mark are the parameter of a line. Okay, so in the MC space you can represent each and every point as a line, and they will intersect on a single point, and now this intersection point can be used to draw a line. So this was the representation of points in a line using MC space using a Cartesian coordinate system. Now let's apply these same concepts which we have learned using the Cartesian coordinate system into a polar coordinate system. So as we all know that in the polar coordinate system we can represent a line using this equation also, which is r is equal to x multiplied by cos theta plus y multiplied by sin theta. Or in other form, you can also represent this equation like this, where y is equal to minus cos theta by sin theta multiplied by x plus r divided by sin theta. So this is your xy space where line can be represented like this, and we are going to transform or represent this line using this equation into the r theta space or the Hough space. Okay, so this line using this equation can also be represented as a point in r theta or the Hough space like this. So let's take an example about this. So as I said, the equation was r is equal to x multiplied by cos theta plus y multiplied by sin theta, where this theta is the angle of the line and r is the distance from the origin to the line. So let's say we want to represent a point which is from xy space into a Hough space into r theta space. So we give the values of x0 and y0, which will be the first point. We can represent this point in the form of line in the Hough space or the r theta space in this formation, which looks like a sine curve using this equation. So this is for the 1 point representation in xy space to a line representation in the Hough space. So let's say you have multiple points. So we take 3 points, then it's going to look like this. So let's say x0 is equal to 8 and y0 is equal to 6, x1 is equal to 4, y1 is equal to 9, and x2 is equal to 12 and y2 is equal to 3. So we have 3 points in the xy space. They can be represented in the Hough space using 3 lines. And as we have seen in the Cartesian coordinate system, these points can be represented in these lines in the Hough space in the polar coordinate system also using these curved line. And this intersection is going to represent a line in the Hough space. So which representation we are going to use in order to use the Hough transform? So this equation is not able to represent the vertical lines. That's why generally we use this equation or polar coordinate system in order to use Hough transform. So the Hough transform algorithm involves these 4 important steps. In the first step, edge detection is done using Canny edge detector or any edge detection method. In the second step, mapping of the edge points to the Hough space is done, and all these edge points are stored in an accumulator. In the third step, interpretation of accumulator to yield lines of infinite length is done, and this interpretation can be done by thresholding or any other constraint. The fourth step involves the conversion of infinite line to finite lines. Now OpenCV implements 2 kind of Hough line transforms. The first is the standard Hough transform, which is done using HoughLines method. The second type is the probabilistic Hough line transform, which is done by HoughLinesP method. So this is the HoughLines method and this is the HoughLinesP method. So the implementation of these 2 methods in OpenCV we are going to see in the next video. So stay tuned and I'm going to see you in the next video.